Now we have the next speaker, that is Daniele Molteni. Daniele Molteni is the product manager from Cloudflare. So he will be running to switch microphone with Andrew. And it will be interesting to know what he speaks us about how to detect the 0 day before the 0 day. So please stay with us, and I'm sure you will find it truly interesting. The time is running now.
Perfect. Hello. Hi. My name is Daniele Molteni. I work at Cloudflare, based out of London. For who doesn't know Cloudflare, we are a cybersecurity company, and we offer a broad range of products to secure your organization, from application security to zero trust, to securing actual networks and location, whether on-prem or on the cloud. And today, I'm going to talk about 0 days. And we're going to talk about how we use artificial intelligence and machine learning to detect 0 days before the day 0, which basically means how do we are so proactive that we can be one step ahead of the attackers and identify those 0 days before they are made public. So we're going to start with a little bit on a bit of a discussion on why WAF is important, what's the value of a WAF, Web Application Firewall. Of course, the traditional WAF are based on signatures, so we're going to discuss why signatures are important and why they're here to stay. And then we're going to talk about how machine learning fits into the picture. OK, so what's the main value of the WAF? So Web Application Firewall has become one of the cornerstone of application security, right? So if you have an application on the open web or an API, usually a WAF is needed, right? You need to deploy the WAF. And historically, the WAF has become basically a click deploy, or very kind of like a simple deploy in front of your application. Some people claim WAF are not sufficient, right? So if you ask to a purist, they probably say, yes, WAF is great, but if you give an attacker enough time, they can bypass the WAF, right? But of course, if you run a bunch of software on your backend, you will need a WAF for patching, for giving you enough time to protect and deploy a patch on your software before you get basically compromised, right? So who is right? Do we need a WAF still? And can we do anything to protect application and protect from bypasses? So there are many vendors, of course, out in the market offering the WAF, and every vendor has a version of this slide, right? So you look at the traffic and say, this is how much traffic there is out there on the internet, this is how much we block, and how much we believe is an attack, is a threat. So on average, we block about 6% of all HTTP requests, which is a pretty big number, right? And another important, I think, very interesting number is the one on the top right, which is the 11% of what we block is still a CVE-related traffic. So those are still like 0-day vulnerabilities. So these are either vulnerability scanners trying to identify the next target, or actually hacker trying to steal data and try to break into an application. And it's a relatively, I think, big number if you consider how much traffic we process. So for example, at Cloudflare, we process at peak 80 million requests per second, on average something like 55. So if you look in that perspective, these are like a lot of attacks, right? And we need to find a way to efficiently identify attacks from good traffic without blocking legitimate traffic. So the time to mitigate a new CV is an important value, right? So it's not just I'm blocking the CV from 2018, this vulnerability from 2019. It's also when a new CV is made public, a new attack is released or is made available, then the time you start blocking that CVE is important, right? And of course, the time it takes for you to block, that's until you have a protection, that's a period of time where attackers can hit your application, identify you as a target, and try to perform their attack. So how much shall we target? So from the moment we have a new CVE, a new attack made public, to the moment we have a new rule, shall we target for 24 hours, 6 hours, 30 minutes? How long? So we can look at the data to try to answer that question. So this is, for example, Log4j. You might be familiar with this. This was one of the biggest vulnerability ever discovered and released for the internet. Of course, we knew about the attack, and we started creating a rule. So our analysts started to create a rule, and we had a rule in place 19 hours after the attack was made public. 19 hours, you might wonder how many attacks were in these 19 hours before. Of course, we don't know, but we can track what happened after 19 hours, and we see that the majority of traffic started 24 hours after the CVE was made public. So we should say, yeah, okay, we're good. We had the rule 19 hours, so we're fine. Another example is a CVE from Atlassian. This was released in June 2022. In this one, we're a little bit faster, so we released a new rule in 3.5 hours. So, and again, the first attacks were 24 hours after it was made public. So we might think, again, we are good. We had a rule in place before the big volume of attacks happened. However, this is not true, because if your organization is the target of some hackers or some activist groups, and they realize there is a new CVE, a new vulnerability, they can target you within that time frame, right? And we might not even see that in the data, because it's just a needle in a haystack. So technically, you should have that protection in place from the moment the new attacks, the new CVE was made public. And this is what we're trying to achieve by adding one extra layer to the WAF, one extra layer of intelligence. So traditional WAFs are based on signatures. So signatures are essentially rules, right? So a WAF is a collection of rules, regular expressions mostly, that are designed to have a very low level of false positives and a very specific and high level of true positives. So you want to be really specific on when you identify an attack and be very sure that was an attack and block it. It's essentially a negative security model. You define what you don't want. The problem with the signatures is that humans write signatures. So you need security analysts that look at the attacks, look at the attack traffic, and then create those rules. And of course, the problem is that humans take time, they need to think, they need to create those rules, and it's a very challenging process that takes time. As you have seen, it took us 19 hours, 4 hours to create a rule, and that's actually a very fast response. At Cloudflare, we have more than 350, 380 signatures, and it's very easy to deploy them. You just click them and you get the protection. But again, it's not enough for new attacks. So this protects you for old attacks, nothing for new. For new, we need to engage and create those new rules. This is an example of a rule. You see, again, it's a regular expression. This is where the IP and if you want, the secret sauce lies and needs to be tested, need to be crafted. It's a very long process. So how do we reach time to mitigate zero? How do we close that gap between having a CVE available or made public and the time we have a rule? And of course, I need to mention AI. Nowadays, everything is AI, but it's true. We use basically machine learning and AI, and we pair that to what humans and security analysts build. Okay, so let's take a deeper dive into how this works under the hood. So there are a few steps we need to take to make sure that the AI component, the machine learning, is effective on real traffic. So the first one, for whoever works with machine learning knows you need a training set, right? So you need something that tells the machine this is what bad traffic looks like and this is what good traffic looks like. And fortunately, we're in a good spot here because, again, we process so much traffic at peak, around 70, 80 million requests per second. We have signatures and rules already running, so we can generate this stream of attacks. So we can use this stream of attacks to train our model and teach it, okay, this is what an attack looks like, right? The biggest challenge here is, of course, to sanitize the data. So because we are handling PII, sensitive data from our customers, the question is here, how do we remove that from the training set? But of course, that's something can be done at scale. Second step is how do we enhance that training set? So if we just teach the model, if we just train the model with that set of attack traffic we have, we achieve a 60% classification performance. 60%, I mean, if I present you an attack, what's the likelihood that you're going to identify that correctly? And that's just 60%. And the reason is because, of course, what you're training the model with is a very limited, a subset of all the possible attacks you can see in the wild. So to cover that gap, what we do is to enhance that training set by using fuzzing techniques and adding like random characters, and so trying to mimic what an attacker would try to do to penetrate your application. We basically introduce variation, artificial variation. And adding this step improves the performance from 60 to 97%. So pretty good. So we have a better way to train the model. The third step is a problem which is very specific to Cloudflare, and if you want to HTTP traffic, right? So because we are a proxy, so we sit in between the client and the server, we need to be extremely performant, right? You don't want to introduce any additional latency, because of course we know that latency is a bad impact. If you're an e-commerce site, this will gonna bring down your conversion rate. There are all sorts of problems. So what we needed to find is a very, very efficient tool that could be deployed across all our servers that can inspect the traffic very, very quickly. And to all customers, they ask me, the first question they ask me, okay, this is great, we use AI, ML, it's all fancy. How much additional latency do you add to my request? And just to give you a quick idea, P90, so 90% of all requests are below 1 millisecond. So it's barely noticeable. Well, you can't notice 1 millisecond additional latency. Step number 4 is more about the data plumbing. Okay, you have a great model, you can run and detect the attack, but how do you deploy this and run it across a massive network and across a network that processes, someone says, between 10 and 20% of the whole internet traffic? This is how much traffic we process. And there are a lot of steps you have to deploy, you have to clean the HTTP request, you have to normalize the request, extract the features. So from the text-based HTTP request, how do you extract the features you care about, run the features through the ML model, and then the model run the inference, and then it spits out the answer. Is it good or is it bad? Okay? So what we built is not just a, is it good or is it bad? It's not just a go or no go. It's more like a score. It's more like a likelihood, a measurement of the likelihood that a request is malicious or not, or is safe. And this is what we present eventually on our product. So this is how you interact with the data in the prettiest form. So here you see a time series. You have time. Each bar is the total traffic that was addressing this specific application. So this is our blog. So we get quite a bit of traffic. You see it's color-coded based on the likelihood that there is an attack. So you'll see green, 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 green. That's all good. And then at some point you see a spike in red, and that's attack traffic. That's where we identify the request, which has a low score, which basically means it's malicious. And of course, this is how to how you interact with the analytics. You can drill down, look at the different data, where those data come from, countries of origin. You can do all fancy analysis, but you can also create rules, simple rules that block future requests that have been flagged as malicious by the model. Okay, how does it perform? So how do we know that what we've built actually brings back the time to mitigate to 0? If you remember, that was our goal. Our goal was, can we block a CVE, a 0-day, before it was made public? So what we can do, we can look at the old CVEs in the past, right? So at the time when a new 0-day is made public, we can look back and see how our model was scoring that specific payload, right? So we can make sure that we already have the protection in place. And here are 3 different CVEs that were released in 2023. One of them was scored as critical, so it was a very high severity. And we look back and we look at the payload traffic and we run the model, and you see at last column, and we check whether the model was already scoring with a low number, which means it's malicious, and the answer is yes. So for those CVEs, we achieved 0 time to mitigate. Of course, this works extremely well when attacks are a variation of existing attacks, of well-known attacks, but we have seen this to be extremely effective with bypasses, with new CVEs as they are made available. So any customer, any user who had this in place at the time those attacks were made public, they would have been protected. So if you were a target of a malicious actor, and this actor wanted to get into your application with these payloads, they would have been blocked from the moment 0. Okay, so where do we take this next? So this is great. We have an old, if you want, old WAF, which is based on signatures. We have a new, shiny tool, which is based on modern machine learning. How do we combine the 2 things? What's next in the future for a WAF? So to answer that question, I think it's great to look at the data. So here you see 3 bars. The first one on the left represents all the traffic that the machine learning model has identified as malicious. The one on the right, you see what the signatures, our rule-based system, has identified as malicious. And then there is a difference. That's where those are the requests that the model flagged as suspicious and the rules didn't. And this is what's interesting, right? So you can basically give those attack traffic to the security analyst, to humans, that they can analyze the payloads, and then they can create rules to protect also against those requests. So essentially what we are building is a reinforcing positive feedback loop, which is a fancy way of saying, I have a model that spits out a result, and the result can be used by humans to improve the rules that conversely improve the training set to improve the model itself. So you're kind of reinforcing this loop by making the signature better thanks to the output of an AI model. And I think this is what we see a lot in the AI ML industry. So this kind of like synergy between what the model provides, the output of a model, and what humans can do to improve the accuracy of that model. Okay, so to recap and to wrap up, I think, yeah, so to answer the original question, can we have a system that brings time to mitigate to 0? And the answer is yes. It's a very hard problem to solve, but with the right tools in place and the right model, you can do that. What we still recommend anyone using a WAF is to deploy all protection. So although this is a great tool, we still recommend to have a layered approach. So you deploy a machine learning tool, you deploy traditional signatures, you deploy all tools you have at your disposal to make sure you are protected against all type of attacks. And yeah, to mention everyone that basically as soon as you start proxying your traffic from Cloudflare, you get benefit of this tool. So it's not restricted to any specific group of customers. That's all from me. Thank you very much. So if you are interested to learn more, you can visit us at the E14 booth. We also have another session later today on Zero Trust. So if you are interested in the problem of securing your workforce, there is also a session there next to our booth. So if you want to learn more, join us there. Thank you very much.